Have you ever wondered what actually keeps the digital world running? Every time you send a message, stream a video, access cloud storage, or make an online payment, there's an entire invisible infrastructure working behind the scenes. That infrastructure is information technology. Information technology, or IT, is the backbone of modern civilization. It powers banks, hospitals, governments, businesses, and global communication. It connects hardware, software, networks, databases, cloud systems, and security into one coordinated ecosystem. But here's the problem. Many people learn tools. Few understand the system. In this lecture, we're not just going to talk about random technologies. We're going to break down the fundamental pillars of information technology, from hardware and operating systems to networking, cybersecurity, databases, and cloud computing. More importantly, I'll show you the complete roadmap. Where to start? What to master? How everything connects? And how to move from beginner to advanced professional. Whether you're a student, a career switcher, or someone who wants to truly understand how the digital world works, this lecture will give you a structured foundation. By the end of this session, you won't just know what IT is. You'll understand how the entire ecosystem fits together. Let's begin. Information technology, IT, is the discipline that focuses on using computers, software, networks, and systems to store, process, secure, and transmit information. While computer science studies computation and algorithms at a deeper theoretical level, IT is more applied. It focuses on infrastructure, systems management, networking, security, enterprise solutions, practical implementation. If computer science asks, how can we compute this efficiently? Information technology asks, how do we build, deploy, secure, and maintain systems that solve real-world problems? Think of IT as being built on 6 major pillars. Before software, there is hardware. Topics include CPU, RAM, storage, HDD versus SSD, motherboards, input-output devices, servers versus personal computers, virtualization basics. Key concept. Hardware provides computational power, IT ensures it runs reliably and efficiently. Understanding hardware helps with performance tuning, server deployment, capacity planning, troubleshooting. The operating system is the bridge between hardware and software. Major examples: Microsoft Windows, Linux, Mac OS. Core concepts: process management, memory management, file systems, user permissions, system services, shell and command line. In IT, especially, Linux administration is critical because most servers run Linux. If systems don't communicate, they're isolated. Networking includes IP addressing, subnetting, routers and switches, TCP/IP model, DNS, HTTP/HTTPS, firewalls. The Internet itself is built on these protocols. Key models: OSI model, client-server architecture, peer-to-peer systems. Modern IT professionals must understand how data flows across networks and how to secure that flow. Data is the heart of modern organizations. These are the core topics in this area. Relational databases, SQL, transactions, ACID properties, indexing, backup and recovery. The popular systems used: MySQL, PostgreSQL, MongoDB. IT focuses on deployment, scaling, performance, data security, disaster recovery. Security is not optional. The core domains in cybersecurity: cryptography basics, authentication and authorization, firewalls, intrusion detection, network security, endpoint protection, risk management. Some of the threats include malware, phishing, ransomware, social engineering. Modern IT must operate under the assumption systems will be attacked. Design accordingly. The shift from physical servers to cloud systems changed IT dramatically. Major platforms include Amazon Web Services, Microsoft Azure, Google Cloud Platform. The core concepts you should apply in this area: IaaS, Infrastructure as a Service; PaaS, SaaS, Virtual Machines; Containers; DevOps, Infrastructure as Code. Cloud is now central to IT careers. 7. IT project management. IT solutions must be delivered systematically. The topics include Agile methodology, Scrum, Waterfall, risk assessment, documentation, change management. IT is not just technical, it's organizational. With data protection laws, security standards, industry regulations. The concepts include IT auditing, policy creation, access control, incident response planning. Roadmap to master information technology. Let's design a structured roadmap. Green Circle Phase 1, Foundations. Basic computer hardware. Operating system fundamentals. Networking basics. Intro to Linux. Basic scripting, Bash or Python. Goal: become technically literate. Phase 2. One path. For Cloud Engineer, focus on AWS/Azure, containers, DevOps. For Network Engineer, advanced routing, firewalls, network security. For Cybersecurity Specialist, penetration testing, digital forensics, security architecture. governments, cloud platforms, global communication. All depend on IT infrastructure. Master the fundamentals, and you can specialize anywhere.